some simple mechanics. So this is, the point A is 1.8 meters vertically above the horizontal ground. And at time t, a small stone is projected upwards and with a speed of u meters per second from the point A. At time t, the stone hits the ground. Speed of the stone as it hits the ground is 10 meters per second. And in an initial model of the motion of the stone as it moves from A to where it hits the ground, stone is modelled as a particle moving freely under gravity, so it doesn't have any mass. The acceleration due to gravity is modelled as having magnitude 10 meters per second to the -2, which is normally 9.8. Using the model, find the value of u. So u, let's just go through and do suvat. So suvat is going to be 1.8 meters for distance. And I know that's just A, but that's the displacement anyway. U, we don't know, that's big U at the moment. V, now it's going downwards when it hits, so it's going to be at -10 meters per second when it's going downwards. A is also going downwards because it's gravity, and so that's -10 meters per second squared. And T we don't know. So we're going to use this one. We're going to use V squared equals U squared plus 2AS. So that means -10. Oh, it's equally going down to that, so let's use a minus on that. So -10 equals 0 plus 2 times -10 times -1.8, and this is squared. Okay, I'm definitely having a few issues with my pen today. This is squared, so that would make that 100 equals 0, or u plus u squared plus 36, and that means 64 equals u squared. Let's keep that u squared. Therefore, u equals ±8 meters per second. And because that was the thing going up, we're going to say that u equals +8 meters per second. Okay, now t value, 1 second. The value of t, we're going to write all this out again. So now we know that if we go through and do S suvat for this, we get S equals, well, it's still going to be 1.8 meters. Except we don't really know how far it's gone because it's going to have gone up a bit and gone down. But anyway, u we do now know is 8 meters per second. V equals, and that's still going to be -10 meters per second. A equals -10 meters per second squared. And then T, we don't know what that is. So the one that works for this would be V equals U plus AT. So let's put that in. So we've got -10 equals 8 plus -10 times T. So that means that -18 equals -10 times T. I took 8 off both sides, and let's just go 10T. And so -18 over -10 equals T, so T equals 1.8 seconds. Okay, or 9/5. Suggest one refinement. I would say this is not beautifully laid out, but it's quite hard to do on this. Suggest one refinement apart from including air resistance, which would make the model more realistic. So more realistic would be if we included wind speed, possibly the fact that it goes up before it goes down, and there's quite a few different things that would make sense for this. In reality, the stone will not move freely under gravity and will be subject to air. Oh, and also the stone has mass, which does make a difference to all the forces around it. D, explain how this would... So it is subject to air resistance. So it would slow down going up. And then air resistance would affect gravity, affect its speed going down. So that's what happens there. Right, that's the first question done.